Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet Research and professional physicist. And today I'd like to bring to you another one of my articles. This one's entitled Missing Geomagnetic Storm. CME follows curved path due to Planet X. Now, figure 1 below shows the sun erupting with plasma on May 12, 2019 in what is called a coronal mass ejection, or CME. It continues moving away from the sun on the 13th, but it does something surprising. The plasma at the head of the eruption seems to move backwards toward the sun. So here you can see the CME starting, progressing. You can see how it's progressing. But now there seems to be more plasma there, a lot more. And then, instead of keeping on moving away from the sun, it actually seems to move backwards. So it's not getting further away from the sun, it now actually seems to be getting closer to the sun. But yet it seems to be progressing on the side. So that means that it didn't actually move back towards the sun. What it did was it changed direction. It didn't move out in the same direction it was moving in, it actually curved towards where the detector is. Or it changed its direction of motion. So now the only possible reason why this would occur is if another object was attracting the plasma and that object suddenly moved, causing the plasma to follow it. The object had to be a Planet X object, which are known to induce solar plasma ejections, or CMEs. So here you can see how far the plasma had gotten. You can see how it is evolving, how it's motion. It's moving fast. Okay, so from there to they reached the edge of the image here. Well, it had reached on that side. And this part here should have moved further out, but it didn't. It actually seemed to move back towards the sun, whilst this side moved a little bit further. So this indicates that it curved towards where the detector is, which would be here. And this is illustrated by this diagram. So what happened was, the CME started going out, there's stereo A, the detector, and then instead of keeping on going this way, it curved in this direction. Why did it do that? Because the ejection in the first place was towards the object that was here. Once the ejection had started, the object moved. And when it moved, the direction of motion changed. The object moved this way. And the object must have been slightly below the ecliptic, so this is the top view. So this would be the sun's north pole here. So we're looking from above. And here's the side view. This is the ecliptic plane. So that's the plane where the planets orbit the sun. Or they all orbit around this plane. So the object would have been slightly below, because the ejection seems to have been towards below the ecliptic here, slightly below. So the object, that's where it was most likely, somewhere there. So if we have a side view, that would be it, and then it curved this way, out of the plane of the screen.